Okay, here's a couple of more solutions from our binomial expansion practice problems. Number 8, we're told that the fifth term in this expansion is 10 million and something, x to the power of 7. Find all possible values of k. Note the plural value suggests that there's probably more than one k value that's possible. But let's not worry about that now. Let's get our setup first. Now we have a binomial that's missing a part. We don't know what the second term is in that binomial, but we know we have a power of 11, so we need a combination that's 11. Choose something. And we have to make sure we choose the correct number of 2x's and the correct number of k's, such that we get 10 million and whatever, 813, 440 x to the power of 7. And right away you can probably notice that if that's x to the 7, 2x has to be raised to the power of 7, meaning there's only 4 more left, I guess binomials left, to make up the 11 binomials multiplied together here, which means that's 11 choose 4 or 11 choose 7, but I think I'll go with 11 choose 4 because we were told this is the fifth term. And remember, if we go 11 choose 4, that actually is the fifth term because we start counting on 0 as always. So now we go 11 choose 4, and we start to whittle this down a little bit, and of course that's going to be 2 to the power of 7 multiplied by this strange k to the power of 4 multiplied by x to the power of 7. So of course when you raise 2x to the power of 7, you got to raise the coefficient to that power and also the variable. And I would expect you would remember to raise the variable. It's usually the coefficient that gets omitted or missed there. So there's our 10 million number again. We'll just say roughly 10 million. And at this point, there's too many unknowns in that equation, right? But notice the x to the power of 7 at this point is not useful or not necessary because it's that k we're trying to hone in on. So I'm going to erase that, and now I can get k by itself. And I guess by dividing both sides of this equation by this number, which is just a number, 11 choose 4 multiplied by 2 to the power of 7, and that is all gone. And now we have, I guess I can erase that, it will look a little bit cleaner. And now we have an unknown that's raised to a power of 4. And most people probably recognize that some kind of a root is necessary here, and it's not just any root, it's a fourth root, not just a square root. I got to better back this equals off a little bit as well. And I guess I better get rid of the power 4 because we just undid that. Now that is of course an even number, that's an even root, and what's really nasty about even roots is you always have a plus and a minus root when you're taking an even root, or when you're getting rid of an even exponent like we are in this question. And if that's confusing to you, just pretend it's a square for the time being, and you're pretty much, I guess we have that ingrained in your brains that when you're getting rid of a square, you need a plus or minus square root. Well, the same thing applies to any even power, believe it or not. And if it's power 4, you need a plus or minus fourth root. Okay, so let's go to our TI Inspire and punch this in and see what we get. Okay, so here we are. Let's put in a fraction template. So we are super clear what's top and bottom, and then we'll punch in that 800 and whatever. I better not say whatever. What was that again? It was 813440. 813440. That was over 11 choose 4 or 7. I think we'll just say 4 to reduce confusion, and that was also divided by 2 to the power of 7. And that gives us 256. Now, of course, if I take the fourth root of that, I think it's hiding here somewhere. Yeah, it's a control exponent. You can change that to, instead of a square root, of course, a fourth root of 256. And we can see that that is 4. So there's 2 possible answers here for our k. K is plus 4 or negative 4, or simply write k equals plus or minus 4. Okay, and question number 9, very similar to question 8, except we have a messier binomial here, and also it's not entirely clear how we're going to get this magical x to the power 14 term, but we do know its coefficient is whatever that is, something a little over 1 million. So first things first, keep to the plan here. Even though things are messier, this has to be a 10 choose something combination, and I need to figure out the correct number of 2x to the power 5s and the correct number of k divided by x to the power 4 terms so that I can somehow get x to the power 14. So let's think of it still as an equation for the time being, because of course it is, and it's going to need to be if I'm going to be solving for k. It's just not immediately obvious how we're going to get exactly x to the power 14. All I know is my two powers that I pick are going to have to add to give me 10. I mean, I guess you could start right out of the gate by just splitting the difference and going for the middle term and see what it is. This is a little bit of trial and error, but I do find for me personally it's usually a lot faster than making this an algebra problem. Because right now I got 25 x's. Of course, remember you would be multiplying when you have a power raised to another power. I'm not really worried about the 2 right now, but notice I have 25 x's on the top and only, not just the number 20 of course, we have 20 x's multiplied together on the bottom. So this would reduce down to x to the power 5. Not big enough. We need 14. So, we need an eraser too, instead of shaking that back and forth. Okay, so 5 and 5 didn't work. The number was too small, so I'm going to up the first one. I'm going to make that 6 and make this 4. And now I can see that I get 30 on the top and 16 on the bottom. And I guess those are still powers of x's, right? So remember, multiply, and look at that. I got my 14 on the second try, which illustrates quite nicely, and I'm not cheating at all. I'm just, I have no idea what the answer is, if you're thinking I'm making this look easier than it should be. But it doesn't take you too long to figure out the correct powers here, just by a little bit of trial and error. If you're curious, you could let one of these powers be a letter, probably something other than N or X, maybe R, and maybe I can show you. Oops, I didn't mean to do that. Get rid of that. Erase that. We know it's 6 and 4. But just to show you that little algebraic procedure, if you find it more useful. If I want to say this is R, this would have to, of course, be 10 minus R. Those two powers would still have to add together to give me 10. And you would still apply your exponent properties there and then essentially solve for R to try to get 14. Like I say, it's probably a lot more of a hassle than just taking a few minutes to tinker around and arrive at the fact that we need 6 of these 2x to the power 5s and only 4 of these k over x to the power 4 terms. Now here it doesn't matter what you put in your combination, but I'll stick to the plan as always. Put the second exponent in the second part of your combination. So we're getting close now. Let's clean this up and we'll be heading to the Inspire here in a few more minutes. We got our combination, 10 choose 4 or 10 choose 6, but I'll go with 10 choose 4. We got 2 to the power of 6. Again, don't forget to raise that coefficient by this power of 6. And I have, there's our friend again, k to the power of 4. And remember, I have 30 x's on the top and 16 on the bottom, so that gives me x to the power 14. And at this point, we're going to just drop, once I write this out, we'll just erase off and drop off the x to the power 14 because we don't need that to solve for k. We're just going to focus solely on the numerical part here, the coefficient of that term, because of course that's what this expression represents. And similar to the last question, you're just going to divide both sides by that combination. This time it's 10 choose 4 and 2 to the power of 6, and that is all gone. Getting serious deja vu here. I need a bigger eraser. And of course, if we take the 4th root, we can get k all by itself. So let's say 4th root, and don't forget that plus or minus. Yes, I'm warning myself, not just you. So k is going to be plus or minus, a nice big bright red, plus or minus the 4th root of that mess, which apparently should be plus or minus 3, and since that is in our answer key, I'll let you confirm that that is indeed correct. Excuse me. That is indeed correct. You can check that on your TI Inspire.